Hi there everybody. In this video I am very excited to be able to announce the launch of this. This is the AOS 3.5 V2 and this is a frame that's designed to be very easy to build out under 250 grams, and it's designed to be a really great freestyle frame with amazing flight performance for people who want to stay under that weight limit or just want something a little smaller and a little easier to carry around to fly freestyle with. In this video, we're going to be going through the design of the frame top to bottom. I'm going to be telling you everything you need to know about the design of the frame. We're going to be looking at some black box log analysis, and I'm going to be going through this example build, showing you the components that I've used and the components that I recommend for this type of frame, and how it's all put together so that you can get the absolute most out of this really fantastic flying little freestyle frame. It's a lot to cover, so let's not waste any more time. Let's get right into it. Okay, so let's start by taking you through the design of the AOS 3.5 V2 on the bench. And I always like to start by looking at the arms on the frame, because I think the arms is one of the areas that I've made the biggest change. You can see that the strut that did used to come out to the motor has now been moved and is now coming to the middle of the arm, and that the main strut that goes into the center of the frame has been slightly thickened. Now, these changes are the result of some work I've done on topology optimization, which looks at how the geometry can be changed to maximize the stiffness and strength of the arm and also save some weight as well. By moving this strut back on the arm, we make it shorter, and that saves a little bit of weight. It also actually improves slightly the alignment of this strut with the carbon fiber weave, which gives a benefit in terms of stiffness. And again, by making this strut slightly shorter, we get a little bit of an improvement in terms of durability as well, in terms of strength, particularly around this central point here. We've moved away from a 4-screw motor mount to a 3-screw motor mount on this arm. And this is a change that actually I had made on the AOS 3.5 V1, and I've carried it over to the V2. This point here on the arm, particularly on the front arm in fact, is a potential failure point in a hard frontal impact. So I didn't want to put a screw hole here, because if there was a screw hole, then that hard frontal impact could actually cause the carbon fiber to crack here. By having this 3-screw motor mounting and by leaving out this screw in this compressive zone, we actually give the arm a fair amount more durability and hopefully should make it less likely to break in a hard frontal crash. The motor mounting is 9x9 up to 12x12. So depending on what motor you want to mount, you should be able to mount any suitable sized motor on here. If we come into the middle of the frame, we have a typical layout for AOS frames with a brace at the front and the rear, and this X brace in the middle that's cut at 45 degrees. Now this supports the whole arm structure and makes it very, very stiff. And it also provides a lot of torsional stiffness. By having a mounting here and a mounting here, the arm is very stiff in torsion. When shortening this strut on the arm, we create a slightly longer unsupported length of this arm in torsion. And so that's why this main strut of the arm has been slightly thickened to provide additional stiffness against that mode. And so overall, the stiffness of the frame is actually improved, and the weight has also been significantly reduced. All of these changes, as well as some other changes that I'll talk about, save about 10 grams from the weight of the frame. So the frame comes in at about 40 grams now, compared to 50 grams for the V1. The next thing to talk about is electronics mounting. And the AOS 3.5 V2 is very flexible in terms of the electronics that you can mount. In the central position, we have a 30x30 mounting point. Now this will fit something like a 30x30 AIO or the HD0 Freestyle 1W VTX. That will also fit in this central 30x30 position. And actually the reason that I included a 30x30 mount is that I thought some people might want to run the new HD0 1W VTX, and so I wanted to make sure that that would fit. There's also a 25x25 central mount, so that's perfect for your typical all-in-one, like this iFlight Beast. And there's even a central 20 by 20 mount as well. So if you wanted to run a 20 by 20 stack, you absolutely can do. There are also front and rear mounting positions, both 25 by 25 and 20 by 20. So if you wanted to run something like a Caddx Vista, I would put that in the front, and then I would put something like a 25mm AIO in the rear. Now, if you're going to mount like this, in order to have access to the USB port on the flight controller, I would mount the flight controller in the rear and have the USB port facing backwards. That's going to give you the easiest access to plug a USB cable in. And similarly, if you're running something like a Caddx Vista, if you have an AIO in the back, put the USB port facing backwards, and then you can actually plug in very easily from the back as well. This is the same configuration that I've used on the AOS UL5, and in general, I think people have been very, very happy with it. The camera plates on the AOS UL5 are 2mm thick, and they have a universal mounting, so you can mount a DJI FPV camera, something like a Caddx Nebula Pro, or any 19mm analog camera very easily, and you have plenty of movement along these slots to make sure that you can get the camera positioned exactly where you want it, so that it's well protected by the camera plates, but not so far back that you can see any of the camera plates in your FPV footage. And just like the AOS 5 and the AOS 5.5 V2, there's no props in view of the FPV camera with this camera positioning. If you can't see the camera plates, you also can't see the props. So just move the camera as far forward as you need to so that you can't see the camera plates, but that the lens of the camera stays behind the camera plates so that it has plenty of protection. The top plate of the 3.5 V2 has the AOS standard 32 by 32 mounting pattern for a GoPro mount, and here's an example one for the Insta360 Go. So you just screw an M2 screw down through the mount and put a nut on the bottom for these back two, and the front two go down into the standoffs. So it's very easy to mount. The AOS logo is obviously cut into the back of the top plate, but I'm expecting that most people will end up covering this with some sort of battery pad and then mounting a battery on the back. There are two positions for a battery strap on this frame. If you're running in this sort of configuration, there's a central position, and then you can also put a second thin battery strap in the rear as well if you want to be doubly secure that your batteries aren't going to go anywhere, even in a hard crash. So now that I've covered the features of the frame, let's take the top plate off and look at an example build that I've put together. Okay, so now the top plate's off, you can see clearly the hardware that I've got in here. I've gone with the iFlight Beast F7 flight controller. I don't feel confident to use H7 based boards at the moment because of the issues that they have with bidirectional D-shot and RPM filtering. So I'm sticking with F7 and F745 in particular processors for now. You can see that I've got it mounted in the rear and that the USB port is facing backwards. This makes it really easy to be able to plug the USB in to do any Betaflight configuration. If you try and have the USB port facing sideways, depending on the AIO, you could end up with a clash on this standoff, which is honestly not the end of the world. It's super easy to drop a standoff out to be able to plug a USB in, particularly if you don't need to do it that often. But I would say if you are going to be plugging the USB in a lot, just have it facing backwards. It's going to be so much easier for you to plug that in. In the front, you can see that I've got a naked Caddx Vista. So this is to save a bit of weight and to try and keep the all-up weight as low as possible. I've just gone with a naked Vista. You can still get under 250 grams very easily with this quad, even with a stock Vista with all of the extra stuff on it. But I just wanted to save a little bit of weight and make it as light as I can. The camera in the front is the Caddx Nebula Pro. These camera plates will fit the original DJI camera, and you can still get under 250 grams with that. Or any 19mm camera will fit as well. If you're going for an analog build of the AOS 3.5 V2, then you could still put the flight controller in the rear with the USB facing backwards, and you could put your analog VTX in the front. Alternatively, you could use the central mounting position for the flight controller, and then you could put your VTX wherever you like, in the front or in the back. You can see that I have the antenna, and this is an iFlight Sigma UFL antenna, mounted to the arm, and I've started doing this on all my builds, and I found there are quite a few advantages for mounting the antenna like this. The vibration and resonance performance of mounting an antenna by strapping it to the arm is phenomenally better than having it on a 3D printed mount at the back. The weight is much lighter because you don't have a lot of TPU and you can use one of these thin, lightweight antennas. With the DJI system, I find that the signal range and penetration, having the antenna in this position, is excellent, and I have absolutely no problems with it. And also, mounting it like this is very, very durable, because there's no way that this antenna is ever going to get chopped by the props. It's never really going to get caught on anything if you crash in trees or anything like that. So I've never had an antenna be damaged when mounted in this position. The main thing is just to keep this antenna cable just nicely managed so that it goes down and under and it can't come up and get in the way of the props. And if you do that, you're never going to have an issue with your antenna getting chopped or damaged in any way. The motors that I'm using for this build are the iFlight Zing 1504 3100 kV motors, and these are perfect on 4S for this build. The 1504 size is just a little bit bigger than the 1404 that I used originally on the AOS 3.5, and just having a little bit more volume just makes the quad even that bit more responsive and fun to fly, and I would really recommend these 1504 motors. They're also 14-pole motors rather than 12-pole motors, which means that they have less cogging torque and they're a little bit smoother as well. So overall, I would definitely recommend these motors. The props that I would recommend for this frame are these Avon Scimitar 3.5-inch props. I find them to be very well balanced. They're very smooth props and they have excellent prop wash handling because they have a relatively short cord, and the pitch, particularly as you get out towards the tip, is relatively shallow, so they do very, very well in prop wash situations. And they also have plenty of top end as well, so they're a really nicely balanced prop and they fly brilliantly on this type of frame. The battery that I would recommend for the AOS 3.5 V2 is something like this Tattoo R-Line 850 mAh. Now this is a 4S battery, and I find that on these smaller quads, 4S packs are a little bit lighter than 6S equivalent, and you really can't tell the difference in performance. You only really see a benefit for 6S when you move to the larger prop sizes, 5-inch and larger. At 3.5-inch, a 4S pack works brilliantly. If you're not running a GoPro, I would use this 850 mAh pack. If you do want to run a Insta360 Go or a Caddx Peanut or one of these other light action cameras, you might need a little bit more headroom in terms of weight, and so you might want to drop down to something like a 750 mAh. And that will give you just a few extra grams to play with if you need to bring the weight under 250 grams when you're running something like the Caddx Peanut. Okay, so let's get some weights for this build now. So dry, this quad is 132 grams, and as I would normally fly it, which is with an 850 mAh 4S pack and a nice thick squidgy battery strap, would come in at 235 grams, so we're well under the 250 gram weight limit. If we decided that we wanted to run an Insta360, we can add a mount for that and the Insta360 itself. That would bring us to 160 grams all up, which means that to get under 250 grams, we're going to need a battery that weighs less than 90 grams. I don't happen to have one with me now, but the Tattoo 750 mAh pack comes in at 84 grams. So with a 750 mAh battery, you're going to be able to come in under 250 grams with the Insta360 Go. Something like the Insta360 Go 2 or Caddx Peanut is a little bit heavier, maybe 10 grams or so, So if you want to keep that under 250 grams, you might need to drop down to something like a 700 milliamp hour 4S, but that battery size is still going to be absolutely perfect on something like this. And you'll still get 3, 4, 5 minutes of flight time, no problem.
Now, it wouldn't be an AOS frame launch without a thorough black box log analysis to determine the vibration and resonance performance that you can expect from the frame design. And we're going to start by looking at a gyroscaled spectrogram on the roll axis, and we can see that overall the frame is very quiet. There's very little vibrational energy across all frequencies, but particularly below 200 Hz, the frame is exceedingly quiet. And that's really important for our filtering, because we're going to want to put our D-term low pass cutoff somewhere in this range here. And that's going to preserve the low frequency information that the D-term needs to be able to respond quickly to what the quad is doing, but it's going to be filtering out all of this high frequency noise from the motors. Looking at frame resonances, we can see there is just a slightly brighter spot here at 208 Hz, which corresponds to a resonant mode of the frame, but it's barely visible above the broad sweep of motor noise, and certainly it's not a big vertical stripe that we would typically expect of a frame resonance. If I show you the mode shape, we can talk about why it's not very visible. The mode shape is a torsional or twisting mode. You can see the motors rocking together and then apart. Now, on a traditional frame that just has a single arm coming out to the motors, it would be very susceptible to this twisting. But on the AOS 3.5 V2, we have this strut here that comes from the back of the frame and the front of the frame and meets the arm midway. And that strut is providing a lot of additional stiffness to that torsional mode. And so the frequency is raised much higher, above 200 Hz, and also the amplitude of that vibration is reduced a lot. And that's why it's so difficult to see it in the frequency versus throttle plot. If we look now at the pitch axis, we can see that the story is very similar to what we saw on the roll axis. Overall, the frame is very, very quiet at all frequencies, but particularly below 200 Hz, there's this very, very quiet band, which is just perfect for putting your D-term filter cutoff in there. The broad sweep of motor noise starts at about 200 Hz, as we would expect. And as we go up in frequency, we can see that there's just a slightly brighter spot again here, which corresponds to a resonant mode on the pitch axis. And I'll show you the mode shape of that. And again, it's one of these torsional modes. So the motors are twisting, but this time, rather than twisting together and apart, they're both twisting forward and backwards. And that's causing the body of the frame to rock forwards and backwards, and so we can see it clearly on the pitch axis. Again, this strut here that comes out halfway along the arm is really increasing the frequency of that vibrational mode. So it's pushing it up to 300 Hz, which is way high enough that the RPM filters and potentially the dynamic notch could be used. The vibrational mode doesn't extend out of the motor band. So again, I don't think we would necessarily need a dynamic notch filter to take care of this. I think it will be well handled by the RPM filters. And that's the benefit of this additional strut here, that it's just controlling that resonant mode and reducing its amplitude so that it becomes less of a problem and we need less filtering to deal with it. Finally, let's take a look at the yaw axis, and we can see again the same story. The frame is very quiet across all frequencies, with a particularly quiet band below 200 Hz. And we can see some evidence of that resonant mode on the roll axis here, but it's again just a slightly brighter area, well within the main sweep of the motor noise. So again, it's going to be well taken care of by RPM filtering. In summary, we see very little vibrational noise below 200 Hz and only a single resonant peak visible on the roll and the pitch axes that is well contained within the broad sweep of the motor band. And what that means for our filtering is that we're not going to need any gyro low pass filtering at all, and up to a single dynamic notch, but I would recommend that you don't use any. I'm not using any. The main filtering on this frame is going to come from RPM filtering, which is going to be taking care of that broad band of motor noise, as well as those slightly bright areas that correspond to the frame resonances. And because we have this very quiet zone below 200 Hz, we can use very aggressive D-term low-pass filtering, which is going to give you really excellent prop wash handling and overall flight performance.
I hope you enjoyed this rundown of the AOS 3.5 V2. If you're interested to check the frame out for yourself, you can order one today. If you're in the USA or Canada, it couldn't be easier to order the AOS 3.5 V2 from cncdrones.com. They're a manufacturer that cuts the frame to order, and they're based on the US-Canada border. Not only do they cut the frame in black carbon fibre, but also in a choice of colours: blue, gold, green and pink for the AOS 3.5 V2. So if you're looking for something a little bit more exciting, a little bit more personalised, check out those colour options and see if any of them appeal to you. I'm always working to expand the range of manufacturers who cut my frames, and you can expect to see the AOS 3.5 V2 with a number of manufacturers in the coming weeks, probably starting with iFlight and Armatan Productions, and then hopefully Farron's Frames in Italy soon after. If you're looking to buy from a retailer, shops like Unmanned Tech and Your FPV in the UK, Elefun in Norway and Get FPV in the US often carry AOS frames, so keep your eye out on those stores for the AOS 3.5 V2, and I'm going to do my best to try and get it stocked in as many retailers as possible. All of the AOS 3.5 V2s that will be available through retailers are manufactured by iFlight in black carbon fibre with black standoffs, and if you have a retailer that you prefer to use and you'd wish they carried AOS frames, then have a look if they sell any other iFlight products, iFlight motors, flight controllers or frames, because if they do, that retailer would be able to order AOS frames from iFlight directly in exactly the same way that they order any other iFlight products. So drop them an email and see if they'd be willing to carry AOS frames in the future. I'd sure appreciate it. That's all I have for you for today, so until next time, I wish you all very, very happy flying.